back on mains power, and I can see there's a residual voltage in the system. I'm looking at the 6L6 pin at 12 volts and dropping, and I have the standby switch down here, and I'm going to flip it on now. We're going to take a look at what happens. Now we can see a 484. Again, high. There's nothing in this amp right now. Now I'm going to flip it off. And we can see that the voltage is now dropping. So it looks like everything's working now. I've loaded in all of the smaller tubes here, the 7025s, the 12AT7s, the 12AX7s. And I've added on the 6L6s. Turn the amp back on. Notice the voltage is still dropping. I still have it in standby. Now on standby, it drops significantly when its standby switch is initiated, right? As I said, still in standby, and this is where I want to be right now. I don't want any high voltage. I'm going to go through now and inspect for that. So just to show, bypassing the switch here for a moment, this is our filtered rectified voltage. We're looking at 472. Chart shows in and around 460, but I do have the standby switch on, so I'm not passing judgment yet. A little bit high, right? A little bit high, but with the switch cutting that off, it's hard to say. That being said, right, I go right next to it to our B plus and all of our high voltage DC. Nothing at all. Exactly what we want to see. Look at the tube sockets. No DC whatsoever. I go around obviously to these to the 12AX7s and the 7025s. They have a quick glance here, right? And there's just no high voltage is what I'm trying to say. And this is where I wanted to be from the get-go, because in all actuality, I mean, what I really wanted to do was have all these tubes in and measure the filament voltages, right? So this is getting back to square one. This is what I want to do now. So the first thing I'm going to do is come right off of the pilot, right? It's one of the first tests that I do here. And I'm seeing 6.6 volts on the pilot. That's pretty good, right? So now I'm going to take a look at the tube sockets themselves. 6L6. Looking at the tube sockets confirms the same value. As a matter of good practice, before I take this out of standby, I got an 8 ohm speaker that I'm going to hook up to this unit. Even though I'm not going to be producing any sound, I always try to match the output. Now what I'm going to do is take it out of standby. I have the multimeter sitting on pin 3 of the 6L6. Definitely heard something out of the speaker there. Sounds good too, no hum. It's not a quality speaker, it's just a test speaker. But I'll tell you right now, it's not too far off. Yeah, not bad at all. Cool. So this thing's alive. I'm going to start taking some voltage measurements here. What I want to see first and foremost, I want to see what the, disconnect this, I want to see what the voltage is now of the rectifier. Yeah, and that dropped now. That's showing 430, 437, 438, right? When I had it in standby, 475. That's a drop right there, huh? But it's not really a major issue. I actually had a fluctuation with my variac, which is a problem I have. I have to stay on top of it because as I draw a significant current, the variac voltage goes down. So I've brought that voltage back up, and what I'm having now is a rectifier voltage of 456. That's only 4 volts off from specification, so that's pretty much on the money, right? And I'm seeing a pin 3 voltage of 455, right? And pin 3 voltage is 460, so that's only 5 volts off. That's dead on. So as far as adjustments for that, and this is what I was talking about with the with the resistors on the other side is that those resistors should only be adjusted based on the type of voltages that you want to produce for the DC, and not exactly, so if they would rise a little or whatnot or change, you shouldn't jump out and change those resistors by the electrolytic capacitors unless you have to. And when you do have to, they should be changed depending on what type of voltages you want to get. You're off by 5 volts. That's just absolutely beautiful and shouldn't be messed with. Also point out for the record, at 120 volts sitting idle like this is 100 watts, 1 amp. I also said that I would not be touching the potentiometers. I'd be leaving them alone until such time as I saw they would need to be messed with. They need to be messed with. So the potentiometers are dirty, right? And that's confirmed. However, and this is before I'm doing any voltage measurements. There's nothing connected to this. This amp is quiet. Just a little hiss. No hum. I've asked the missus to plug in her guitar right quick just to demonstrate that all these pots are gone. Working them is helping, but they all need to be cleaned. I'll try and get it where it works. We're just trying to see what the conditions of these potentiometers are. And there's the bright switch. This is what we're going to do just to get our testing going. I'm going to shut off the amp first, right? So, I'm going to shut this down. And I'm going to give Deoxit to these 3 right here because they really need it. All 3 of them are terrible. These 4, I mean. Not going to work them. This is not my favorite job, but this stuff really does the trick. I brought everything back to 1. I'm going to turn the amplifier back on. I'll give it just a second. Again, everything back on 1. You twist these things. You don't want it sitting on 10 when you fire this bad boy up. And I've got it back up and running. I'm going to bring the volume up first. And there's no more crunch. Nice and smooth. Go ahead, give it a strum. And I'm gonna check out. I'm gonna leave this here, right there, and I'm gonna try these out. That sounds a lot better, right? That one sounds good. I'll drop that right here at 4, and now this one. Go ahead. This here at 4, and then the final one. Go ahead. There's too much bass for this little speaker, but it illustrates that the knobs are now working nicely. Okay, go ahead now. Give it a. Okay, very good. So those are cleaned up, and we'll do the rest of them as well in time. What I'm going to have to do is clean these contacts to make sure the grounds are good. A piece of 400 grit sandpaper that I've folded in half. What I'm going to do is I'm going to take a screwdriver here and just put it in the contact just to open up the contact to get the sandpaper in, right? So bring it all the way to the bottom, just like that. I'm just going to pull it up and clean the contact. Once or twice is all it takes. And I'll do the same thing with the other contacts. So this is the point where I go and I collect all of the values, all of the voltage readings that I can that are annotated on the schematic diagram and the wiring diagram. I actually work on the wiring diagram because I find it easier, right? I'm going through each and every one in the in sort of an idle position here, capturing those values, and I will eventually transpose it to the schematic diagram, and in looking at those values, find the outliers and see if they all align themselves to one of these here junctions where these voltage dropping resistors are, or if it's right off an individual tube, so I can make any determination as to what resistance needs to be changed, right? I'm not going to do that just yet. I'm just recording the values. I want to point out that when you're taking measurements of the voltage of the 12AX7, that the vibrato has to be turned on. I use a shorting plug to that end. And even though it is a little bit subjective, because based on what the dials are in the front, we'll change these values slightly. I've turned them up just a little bit just to initiate that circuit right there. And I've come to find the values are close enough to say that it's good. So that's one of the idiosyncrasies here during the voltage measurement of the tube sockets. I've transcribed the voltages onto schematics, and then from those voltage differences, I've derived percentages, right? The percentages are shown in the squares, and the ones that are annotated in orange fall outside of my parameters. This thing is actually within the 20% as specified. I flag everything that's above 10%, even though I don't really have to, but it's just something that I look at, right? And I'm down to 3. This one, I know I have a resistor that's higher than it should be, so I'm just going to look at that separately. As for this right here, these 7025s, we could see this one is 19% off and 12% off. This one is 4.2% and 7%, so this is a little high, this is a lot high. Trace this back, follow the blue here. Come to find that this is 410 volts coming in here. The other one that feeds off it, off of this 100 ohm, is good as well, right? So what I'm going to do first is just, as a measure that I always do, is I'm just going to swap these 7025s and reread them. I don't know why I do that. It's just something that I do, and we'll see what the results are. And as long as it doesn't follow the tube, I'm going to evaluate how I can adjust the bottom. I'm not worried about the top ones, but I'm going to adjust the bottom ones to bring them back into specification. I swapped these two 7025s right here. This is the normal and the vibrato. In doing so, this section here, pin 6, voltage comes up, but it doesn't come up in excess on the first one as it does on the second. The second one shows 290 for 240. By swapping them, the second one dropped down to 270, right? So I'm going to leave them swapped, and that brings them both in the specification. I'm going to redo the numbers, but everything looks like it works right, and that's going to close it out. I suspected it was the tube and nothing to do with the amplifier, because all of these resistors were good and the input voltage was correct for what I was working with. I realize that it can be easily seen in the video, so I take a moment here to look down. This is the current going through one of the vacuum tubes that I'm monitoring as I do my other work. I have set the bias based on the current, based on the plate voltage. As I've done the calculation of 35 milliamps, it gives me on this right now 15.9 watts, which is sufficient. So I just wanted to point that out. What I'm going through is marking this as it sits for a while on a tube and stabilizes at 35 milliamps. As I go and do other work, I shut it down and move to another tube, and I'm making a note of what the drift will be between the tubes, because if one is 35 and one is 39, yeah, I have a deviation of 4 milliamps between two tubes. I need to know that. So after tube swaps and resistor replacements, I have the entire amp for voltages well within the 10% rating now. I haven't updated this section, the annotations yet, but it's all done. So the voltage checking and fixing portion of this project is now over. I didn't walk away from this unscathed. Unfortunately, in measuring the tubes, I had biased it to 35. The second one in the middle, also 35, was very nice. The one on the outside was 37. I'm like, okay, but the one on the right, 40 and a half. Now I got a deviation of 5.5 milliamps, and that's no good. So what we're going to have to do is I'm going to bias it for 35, and what we'll do is we're just going to hand match the offending tube when I take it back, and we'll have it set up for 35 milliamps of bias, unless they would like to use a different bias, and we could rebias the whole thing. But that's my plan right now. I've got the amp up on the bench here, and I'm going to be testing some of the features of Vibrato and the Reverb. Obviously, the best way to do that is to connect it back to the cabinet, especially for the Reverb, because I need the tank, right? I have a shorting plug here that I use in in lieu of a foot pedal, right? And the reverb should be on by default through the vibrato channel. So what I'm just going to do is, number one, I'm not going to be playing any songs here, so y'all don't have to worry, I promise, right? I'm going to take it out of standby. Right? And I got some reverb on there. Hold on. I really got this cranked up. I can't see the dials. This is all the way down, all the way down. And all the way up, well, I'll go midway. Actually, that's yeah, about midway, all the way up to 11. And the acoustics have to sound terrible in this room. This is a small room for such a big amplifier, and I got the volume cranked up. Now what I'm going to do is I'm going to put the shorting plug in, just like that, and reverb is off. Very good. So I'm going to turn reverb back down, take the plug out. It should still be off now. Now I'm going to move to vibrato, and vibrato is off by default. I'm going to have to short it to turn it on, right? So plug in vibrato. We could hear the oscillation already. I'll make some adjustments. That goes down nice and slow. There we go, that's the slowest setting. Now we'll look at fastest. Well, fastest is no vibrato, obviously. But let's look at depth. Depth is no vibrato. And here's maximum. What do they call depth? They call it intensity. Okay, here we go. So that is working too. So I'm going to shut off vibrato. I'm going to pull out the plug. There we go. I don't even know what I have these other knobs on. Here we go now. Now it's nice and quiet. I'm checking the knobs for noise. These have already been cleaned with a Deoxit, but still I'm going through them. Very good. I think this amp is ready to put back in the cabinet. Of course, the capacitor cover is put back on, and I will remove the 6L6s before I put it back into the chassis. There we go. It's all back together. Fire in a hole. Ignition.
I'm supposed to.
Just put it near the jack, try it out. This one should be a little more subdued. That's the bright switch on. I'm going to move it to the other channel. One moment. Go ahead. Isn't it cool?
Sounds so far away.
It does. A little different than the Devil Cat.
Sorry, you won't hear me say that. I love my Devil Cat.
A little different than the Heathkit amplifier.
No comment. I will not discriminate against my amps.
So I hope you enjoyed this video on the restoration and repair of this Fender Twin Reverb amplifier.
Thanks for watching.
Thanks for watching.